Polytechnic Ibu Omar. Purpose we are doing this video is because we want to talk about trigonometry in sport. Our beloved madam who is in charge for this activity is Madam Nur Amalina binti Montel. Let me introduce you guys who is our group members that involved in this video. First member is Muhammad Azri bin Azmi. Second is Muhammad Faiz bin Jami. Third is Nur Alia Maisara binti Abdullah, and the last is me, Nur Adila Sofia binti Abdul. In this video, we will share about history of trigonometry and what is trigonometry. After that, we will learn about trigonometry formula and the application in real life situation. Lastly, we will conclude what we have learned, and also we need to solve the question about trigonometry that is given in the end of the slide.
Number 1 is history of trigonometry. The development of modern trigonometry shifted during the Western age of alignment, beginning with 17th century mathematics from Isaac Newton and James Stirling, and reaching its modern with Leonard 1748. Derived from the Greek words trigonon, also known as triangle, and metrons, also known as two measure. Trigonometry was chiefly concerned with the computation of numerical values from the absent numerical value of a portion of the triangles or shapes that could be dismembered into triangles when the values of other parts were given until the 16th. Second, Pythagoras, Aristotle, or the ancient civilization of the Greeks, Egyptians, and Babylonians may come to mind while looking at the dawn of trigonometry.
Number 2. What is trigonometry? What is trigonometry? Trigonometry is a 16th century Latin derivative from the Greek words for triangle trigonon and measure metron. According to Victor Kass, trigonometry developed primarily from the needs of Greek and Indian astronomers. Trigonometry is a branch of mathematics that studies relationship between the side and angle of triangles. Trigonometry has astoundingly intricate relationship to other branches of mathematics, in particular complex numbers, infinite series, logarithm, and calculus.
Number 3. Trigonometry formula. Trigonometry radius and formula Sakatoa.
Trigonometry radius. There are 6 functions of an angle commonly used in trigonometry. Their names are abbreviations are sine, cosine, tangent, cotangent, secant, and cosecant. These 6 trigonometry functions in relations to right triangle. Relations to right triangle are as shown in this slide. For example, the triangle contains an angle theta of the radius of the side opposite to theta, and the set of opposite to right angle the hypotenuse is called the sin of theta or sin theta. The other trigonometry functions are defined similarly. For your information, there are actually trigonometry formula for a student to easily remember the function of sin, cosine, and tangent, which is so, ca, and toa. So means sin equal to opposite divided by hypotenuse. Next, ca means cosines equal adjacent divide hypotenuse. The same concept goes to toa. Toa means tangent equal opposite divide adjacent.
Number 4, application trigonometry in real life situation.
Question 1.
A player stands 25 meters from the goal line and strikes the football in a straight line at angle from the ground. If the ball strikes the crossbar, what is the angle? I would like to explain the calculation of angle for cross the ball. Tan theta equal 2.4 over 25. Inverse tan minus 1 in bracket tan theta equal inverse tan minus 1. In bracket again with 2.4 over 25. Theta equal tan minus 1 in bracket 2.4 over 25. And you will get the final answer is theta equal 5.5 degrees.
Okay, question number 2. The golf coach want to train his student, but before that, the coach need to know and study the pitch angle and the golf hole. So how to solve the evaluation angle? Round it to the nearest 10.
Conclusion to solve the angle of elevation round the nearest 10. First is theorem Pythagoras. Tan square equal 8 square plus x square is 100 equal 64 plus x square 36. Square root 36 is x square and get x, and x is 6 feet. And since in bracket theta equal 6 over 10 and theta equal sin minus 1 6 over 1, theta equal 36.870, theta equal 36.9, and sin in bracket theta equals 6 over 10. Simplify is 3 over 5, and cos in bracket theta equal 8 over 10. Simplify is 4 over 5, and tan in bracket theta equal 6 over 8.
Question 3. A player who is 6 feet tall gets fouled and he gets to shoot a free throw. You know the rim is 10 feet off the ground and 15 feet from the line. What is the angle from the player's eyes to the center of the rim? Based on the question given, it's already shown that the player head is 6 feet. So, the first thing we need to minus the head to know the opposite. 10 feet minus 6 feet equal to 4 feet. Then we need to find the angle. So tangent equal to opposite over adjacent. You have to fill the value given like tangent equal to 4 over 15. Then you get the answer like tangent equal to 14.93. That's all.
Okay, next question number 4. In a water skiing competition, a jump ramp has the measurement shown. To the nearest foot, what is the height h above water that skier leave the ramp? Okay, so we can see from the diagram that hypotenuse side of the triangle is 26 feet and the opposite side is h, which is unknown, and it has the triangle has a degree 17.7. So given the opposite side and the hypotenuse side of the triangle is present, we can use them to get the answer. So sin 17.7 equal h over 26. Next, 26 multiplied by sin 17.7 equal h and we will get the answer of 7.904. So we will approximate it to 8. So the answer of the question is 8 feet.
Number 5, conclusion, trigonometry in sport. We already said that trigonometry can be used in many areas such as sports, astronomy and architecture. They can aid in calculating many things. They can also be used in cars, dirt and benches. Without really climbing a tree. You can find the height easily with trigonometry. They can be so widely used in real life application, and is very useful for most architects and astronomers. And then we can conclude that without trigonometry, life would be much more difficult. Without going through the troubles, you can easily find something. So we think that it was a good invention by Archimedes, and thanks to this many architects need not go through the trouble to calculate things. So it really helps in real life application, and not only in our test and exam.
Number 6, question.
Hello, the question is in triangle ABC, the B is 100 and A is 9 meter and C is 10 meter, and the question is solve the triangle. And B square equal A square plus C square minus 2AC cos B, and B equal square root A square plus C square minus 2AC cos B, and B equal square root 9 square plus 10 square minus 2 in bracket 9, and in bracket is also 10 cos 100 degree, and B the final answer at B is 14.57 centimeter.
Okay, next, sin A over A equals sin B over B. Sin A over A equals sin 100 degree over 14.57. And then A equals sin minus 1 in bracket is sin 100 degree over 14.57. And the next sin minus 1 in bracket 818.632 over 14.57. And then the answer 37.47 degree.
And sin C over C equal sin B over B, and the next is sin C over 10 equal sin 100 degree over 14.57, and then C is sin minus 1 in bracket 10 sin 100 degree over 14.57, and equal sin minus 1 in bracket 9.8481 over 14.57, and the final answer is 42.53 degrees.
Area of triangle equal 1 over 2 AB sin C. Equal 1 over 2 in bracket 9 and 14.57 sin 2.53 degree, and then the answer 44.32 m square. Thank you.
Thank you.